So guys, now let us discuss the benefits of having thread pool in our application. So application don't have to call pthread create API in order to create new thread, and this leads to the performance improvement. The reason is that the pthread create API is an expensive call as it is a wrapper over a system call clone, and clone is a system call which actually switches your applications from user mode to kernel mode or privilege mode. Right? In fact, this is true for any system call, and invocation of the system call is quite expensive when it comes to the performance of the application, right? In fact, any application which invokes any system call within a for loop or within a quick succession, such an application gives poor performance. It is never recommended to call system call within a loop. So in this case, an application harnesses the benefits of a thread pool by avoiding any invocation of the pthread create API to create a thread, and they just fetch the existing thread from the thread pool to get the work done, right? Consider you have a network application which is processing incoming packets in the context of a separate thread. So let us suppose that you have an application, right? And this application is receiving network packets P1, P2, P3 on a socket, right? Now let us suppose that in order to process the incoming stream of packets, the application launch a thread to process each packet. So let us suppose that application launches the thread T3 which operates on the packet P3, right? And do some amount of computation. So now consider that the application is receiving 10 packets per second. Does that mean that the application have to create 10 threads per second, right? Okay, 10 threads per second doesn't look like a very big number, but what if the application is receiving 100 or 1000 packets per second? An application which is creating and destroying the threads at the rate of 1000 per second is no doubt going to give you very poor performance, right? Your application would go into doom because your application is trying to invoke a clone system call using pthread create API in a very quick succession, right? So this problem can be easily solved using thread pools if your application maintain a pool of threads in which we have thread T1, T2, T3. Then every time the application receives the packet, the application simply fetches the thread, say T3 from the thread pool, assign the packet P3 to the thread T3, and simply let the thread T3 do the processing, right? In this entire cycle, the application is never invoking pthread create function, right? In fact, there is zero creation and destruction of threads by the application. So there are network applications which are designed this way and make use of thread pools in order to process the incoming stream of packets in a context of separate thread. Then thread pools also helps in placing an upper bound on the number of threads an application can create, right? This is useful in resource constraint environment. For example, suppose the limit of the thread pool is say 10, so the application has to work with only at max 10 threads during its lifetime. An application cannot create the 11th thread in any situation. So thread pool also helps in placing the upper bound on the number of threads an application can create, right? Let us see another real-world example where thread pool helps to solve the problem better. Suppose you have a thread which has established a connection with a remote host, can be reused again and again from the thread pool without dropping and re-establishing a connection again. So in this case, you have an application A and we have a thread pool, and the application has created a thread T1, and the application has used the thread T1 to create, let's say, TCP connection with some remote host. Now the application can place back this thread to the thread pool and use it only when the application needs to communicate with this remote host on the already established connection. An application can park the thread T1 into the pool whenever there is no need of any data exchange with this remote host, right? So application can fetch the thread on demand from the thread pool and make the thread T1 to work whenever there is a need, right? Without thread pool, an application would have to destroy the thread T1 and recreate it again whenever there is a need to carry out data exchange with this remote host, right? So thread creation and destruction would have involved had the application was not using the thread pool model of maintaining threads. So you can read about the thread pool more on the internet. For example, this is the Wikipedia, which has a very good text regarding thread pools. So I would suggest to read the Wikipedia of the thread pool or other references which may talk about more benefits that you can get from thread pools. So in the next lecture video, we will start with the designing and implementation of thread pools.